Up guys, Hanos here, and back with another day, another LeetCode problem. I just got showered back from work. My girlfriend just got done showered from work, so I'm gonna make this one short and sweet. Once again, I've done this all week. I know I've said I'm gonna be doing harder problems, but I don't know when my next off day is. If you include school, which I have school Tuesday and Thursday, I work every other day, so it's probably gonna be pretty easy problems up until maybe exams. I mean, school's ramped up a lot this past week. But we're just gonna hop right into this problem. It's day 26. I hope everyone had a great Halloween. I sure did. But this one's the linked list cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that's tails next pointer is connected. Note that POS is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. Yeah, position 1, true. Okay, we don't have to return the position, we just have to return if there's ever a node that equals to each other. The solution I gave for this is it reminds me of the median of a linked list problem. We did that one here on this channel, and we had a slow pointer and a fast pointer. And when the fast pointer equaled null, then we would be at the median node or the middle node of the linked list without having to iterate through the list once and divide the length by 2. It's just one iteration, and then you reach the middle of the linked list. This one should be similar. Eventually, both nodes should equal each other. So we'll go ahead and type this out. So list node slow is equal to head, and then list node fast is equal to head. And then while fast it does not equal null, and then we want and fast dot next does not equal null. So the slow and fast nodes work like this. So we're going to set slow equal to slow dot next, and then we're going to set fast equal to fast dot next dot next. So slow moves one node each time, and then fast moves 2 nodes. So we'll draw this out with the epic pen for the first solution. Oh, it's over here. It's on my other monitor. So given the slow and the fast, right? During the first iteration, slow will move to the 2, fast will move to the 0, and then then the next iteration, slow will move to the next, and then fast is at 0, it'll move to the next dot next. Fast will be here. Next iteration, slow will move once to the 4. Fast will move twice. And if they ever link back up one time, then we know there's a cycle, because fast should always be ahead of slow. So if imagine it's a really long list, fast should always be ahead of it until it reaches null. If for some reason fast and slow ever equal each other, then we know there's a cycle, because they shouldn't ever equal each other besides the first node. So after, we should be able to check if slow is equal to fast, and we want to use the equal comparison because we want to compare objects here, because they are both pointing to the same node object, so we want to make sure that that is equal to each other, and so then we can return true. And then else we want to return false. And if I didn't forget any semicolons, it doesn't look like it. So that works for the first, and then if we submit that, it should work for the rest. Yeah, it beats 0 milliseconds, beats 100%. This video is 4 minutes so far. I think I'm gonna keep it there and end it right here, fellas and women. I mean, I assume it's fellas watching me. But this beats 100%. It's a 0 millisecond and a O of 1 time complexity, O of n. Well, it might be O of like, it's the O of n time complexity. I'm guessing the worst time complexity would be O of n squared, where you check one node and then you keep on going, and then you check another node and you keep on going until one object equals another. And honestly, it might be like a factorial problem if you brute force it. But the slow and fast should work for no matter what it is, because if they ever equal the same node, then it should have a cycle. If not, if there's not a cycle in it, then fast will equal null eventually, break out, and then give us a false. And then the slow and fast will eventually, they will be the same node. It might be 2 or 3 times around the cycle before they ever equal one another again, but eventually it should happen, or it does happen. Yeah, I mean, this problem's not too bad. I do want to end it off by checking out the channel. We're at 168 subscribers, which I think is pretty huge. We're going 25 days straight, 55 views, 47, 114. Yesterday's video was another 5-minute episode. This one's it's 6.5 so far, so I think we're gonna leave it at that. But if you liked the video, be sure to like it. If you have any questions or comments, please leave them below, and I'll try to get back to you as soon as possible. And anyways, y'all stay blessed, y'all stay healthy, y'all keep coding, and I'll catch you on the next video. Hey Devs is out.